Alright, so here is a video on section 3.3 exercises part C. We're going to discuss some of the harder problems. It looks like part C is kind of a review of everything. Um, so the 29 through 31, those are interesting things. Those are unique. They differ from person to person. We'll discuss those in a different video. Right now we're just going to discuss hard problems from this whole thing here. These first ones are just algebra, following the algebraic method. I'll make another video about harder algebra problems and some rules to remember there. So I'll make another video on 1 through 6. Solving for specified variables is going to be a little bit difficult. So let's look at 7. So 2s at squared over 5t equals v. We want to solve for s. Now this for s is important. It's what we want to find. Just like when we're solving for x in another equation, it's what we want to find. Here we need to solve for s. So we need to remove or do the opposite operations to find and uncover s and get it alone. The first thing that we need to do is we need to say this 5t is divided. So it acts like a whole number. 5t you can consider 1 unit. At squared is 1 unit, and 2s is 1 unit. V is also a unit, but we knew that. So we're going to multiply both sides by 5t. Doing so, we'll remove this 5t on the bottom. And this is a rule for fractions to remember. You can only remove fractions if they're alone on one side. If this was 2s plus at squared over 5t plus 2, we would have to subtract the 2 before we could remove the fraction. This removes because the 5t ends up on top and then is subtracted there, and we'll discuss that in another algebra video. Now we're left with 2s plus at squared equals v 5t. And that's all multiplied, so we can write it as that, or we can write it as 5tv, which is sometimes what we'll see. The number comes out front. That's kind of what standard form is. Now, we have a 2s plus an at squared. That means we need a 2s minus at squared to cancel out at squared. If you remember, it's a whole unit, so we can cancel and move it as a unit, which gives us 2s equals v 5vt minus at squared. Now it's 2 times s, so we're going to divide by 2. S equals 5tv minus at squared all over 2. And that is how you would solve that. Just remember that they're numbers and they act like whole units when moving over. I have another video that discusses this subject, so I won't go into too great detail, but that is how you would solve those kind of problems. Let's look at another problem from here. Let's go into one that delves into kind of more a word problem. So if we're going to say we want, let's look at this one. All right. So we're going to say two numbers. So hold on. So two numbers add to 438, and the first is 72 bigger than the second. What are the two numbers? Okay, let's say. So what we know is we have two numbers. We'll just call this one x and this one y. X plus y both add to 438. But x, let's just say the first, equals y plus 72. So how would we solve this? This is done by, it's solving for linear equations. The hard part is Yeah, we're going to end up with two numbers. We have to use two variables because we're going to end up with two numbers. I just looked at the answer just to make sure I was doing this correctly. So what we need to do is this is equal to x, right? This whole thing right here. So anywhere we see x in this equation, we can substitute it. So now we minus 72, combine our y's. Divide by 2. And we get y equals 366 divided by 2. Ah, shoot. 183. All right, so we know our first number. We know one of our numbers is 183. Now we're going to take and plug 183 in for y. So it's going to be x equals 183 plus 72. And when we do that, we get 255. So we get 255. So our two numbers are 255 and 183. So I want to focus less on the math on how I got there and more about how I set up the equation. So two numbers. So I said, okay, two numbers, two different numbers. So x and y. Things I don't know, just two numbers. Add. Okay, so I know there's a plus in between. Okay, so that's how I got this portion right here. And then I said add 2. Okay, so the 2 here. Oops. The 2 there is equals. So that's where my equals sign came in. 438. Okay, so now I have one equation so far. But it tells me nothing because I have two unknowns. So I need another equation to help me solve it. X equals y because it says that the first is, so that's another cue that's my equals sign, is another cue that's where an equals sign is. So the first x is 72 bigger than the second, so 72 plus the second y. And then we solved and came up by substitution. So solving this one, we plugged in y plus 72, solved the problem, and gave us that. So that's something that is algebraic, and you may not have learned it yet. But my main thing is, can you get the word problem set up? I could care less if you can get the math right down here. Is can you get the word problem set up? And so I would focus on how to set this up, and I'll just talk about the next one and how to set it up. And then you guys can do the problem yourselves. I'll just talk about how to set up the problem. So if we're going to take this next problem, if a rectangle's length here, this one will work. If a rectangle's length is 5 more than 4 times the width, and the perimeter is 180 millimeters, what are the dimensions of the rectangle? Okay, so we know something. First off, if I read it again, it says a rectangle. Okay, rectangle. All right, now it's telling me something about the length, so the long side. Okay. So the length is the long side, so I'm going to call that L. 5 more, so 5 plus, because more is plus, then 4 times the width for W. Oh, that's cool. Okay, so then it says that P equals 180. Okay, now it doesn't say anything about W, so I just assume that W is W, because it doesn't say anything about it. And it mentions the width right there and doesn't say anything added to it, so it must just be the width. It says it up here for length. The length is equals, but it doesn't say the width is something, so we're just going to call the width that. Now we have to solve for W using our formula that perimeter is equal to 2L plus 2W. So using that formula, we can now solve for W. And then once we know W, we can plug it in and get the dimensions for our rectangle by solving for this formula, and I have another video on how to do that. But again, like my focus here is just setting up the word problem. So if a rectangle's length, so I knew something. I knew I had to have a rectangle. And then it was talking about the length, so the long side is equals L equals 5, okay, so 5, more, okay, that's addition, then 4 times is multiplication, the width, okay, so that's L equals 5 plus 4W, and the perimeter is 180 millimeters, okay, so the perimeter is 180. I know that I'm going to use the perimeter formula because they gave me perimeter. I also know that this W right here is going to be just W because it didn't mention anything about it in the problem. So that is how you would set up this problem. I'm running out of time for this video, so I'm going to move on to another problem. You can go back and watch that through on how I set up that word problem if you need more help on setting up word problems. They can be tricky sometimes. Let's go to percentages real quick. Yeah, most of this is just pretty easy review stuff, but percentages can be kind of difficult. Let's look at if the price of a meal after a 20% tip was $16.08, what is the price of the meal before the tip was added? Let's do that one since it's a word problem and it's a percentage problem. All right. So let's see. Before the tip was added. So I know that's going to be my X. So if the price of a meal was 20%, after a 20% tip was $16.08. So that's my total. So equals $16.08. Now I gave a 20% tip, so 0.2, not dot 2, not colon 2, just 0.2. And I gave a 20% tip. Now I'm going to multiply that by X. So it's X 0.2X. Because to get a tip, we multiply our total meal and then multiply it by 0.2 and add it to itself. So the way to think of this is we're going to end up with a solid number, 1340, right? But we're going to get something here. So what we're going to do is we're going to get this, and then we're going to need a separate equation, and I'll show you why. So let's do this. So if we're going to divide by 0.2, so 16.8 divided by 0.2. Where's my calculator? I must have closed it. All right, so 16.8, 0.08. So 0.08 divided by 0.2 gave us 80.4. Now that doesn't sound right, does it? What did we do wrong? How did we get such a big number? That doesn't make sense, does it? Let's think of this another way. So I did this wrong on purpose to show you that it isn't set up like some of the other problems that you may have seen. Let's talk about it this way. I think the true setup of this problem will look better if we did it this way. X, we need to find the tip first. So we're going to have X equal the tip. First we need to find the tip. So we're going to say if 16.08 were my tip, I'm going to times that by 0.2 to find what X was. So let's do that. I keep closing my calculator. .22, we'll round up. So X equals 3.22. But that's not our answer yet. We need to take 16.08 minus X to find Y. And we're going to make Y the price of the meal. And that will solve your answer. And you see how it's set up differently from some of the other problems that we have? Because you're given a tip that's added to an original amount. Therefore, in order to get the amount, you have to first find the tip, then find the price by subtracting the tip from the price. So these are some of the harder problems in part C. If you have any specific problems that you're having issues with, email them to me and I'll make a video on how to do it. All right, sounds good.